Hello everyone. The topic I am going to discuss is about engineering properties of food materials, which is and the unit is rheological properties of foods. The topic is about measurement of viscosity. Viscosity. Viscosity is the quantitative measure of a fluid's resistance to flow. It is defined as the internal friction of a fluid. The lack of slipperiness is also called as viscosity. Rheology. Rheology is nothing but a change in deformation and flow. That is the change in form and the flow of matter, embracing elasticity, viscosity, and plasticity. We generally measure two types of viscosity. One, it is absolute or dynamic viscosity, which is given as tau, and second is kinematic viscosity, which is given as mu. Viscosity is the measure of internal friction of a fluid. This friction becomes apparent when a layer of fluid is made to move in relation to another layer. The greater the friction, the greater the amount of force required to cause this movement, which is also called as shear. Shearing occurs when the fluid is physically moved or disturbed, as in pouring, spreading, spraying, mixing, etc. For highly viscous fluids, therefore, it requires more force to move than less viscous fluids. For highly viscous fluids, we can say as honey, butter, etc. And for less viscous fluids, we can say as milk, water, etc. Here we can see the diagram of two parallel planes, which is divided by a distance dx with force F, and dV is the change in velocity. It explains about cohesive and adhesive forces. Isaac Newton defined viscosity by considering the model represented in the figure below. There are two parallel planes of fluid of equal area A, which are separated by a distance dx and are moving in the same direction at different velocities, which is v1 and v2. From the two parallel planes, equation is derived in which the Newton assumed that the force required to maintain this difference in speed, it was proportional to the difference in speed through the liquid or the velocity gradient. To express this, Newton wrote F by A, which is force by acceleration, it is equal to tau by dV by dx, where tau is a constant for a given material and is called as viscosity, and dV by dx is the change in the velocity gradient. The velocity gradient dV by dx, it is the measure of the change in speed at which the intermediate layers move with respect to each other. It describes the shearing the liquid experiences and is thus called shear rate. The term F by A, it indicates the force per unit area required to produce the shearing action, and this force by area, it is also referred as shear stress. Tau equals viscosity, which is tau by rho, which is shear stress by shear rate. Thus, it is mathematically defined as this following. Why? Why should I measure viscosity? The reason. From viscosity measurement, we can obtain much more useful behavioral and predictive information for various products. Frequent reason for the measurement of rheological properties, it can be found in the area of quality control, where raw materials, it must be consistent from batch to batch. That is, for every batch, the raw material, it should have a consistent value. For this purpose, flow behavior is an indirect measure of product consistency and quality. In this, we are going to discuss about different types of viscosity. Here, which is the rate of shear strain, which is du by dy. In this, we can see four different types of lines. The first line, it is about Newtonian. In this, there are two types of viscosity, which is Newtonian and non-Newtonian fluid. As for Newtonian fluid, it's a straight line where it obeys Newton's law of viscosity. As for example, Newtonian fluid example is water, where n is equal to 1. As for non-Newtonian fluids, as you can see, there will be a curve in both sides of the Newtonian fluid, which is shear thickening or shear thinning fluid. Shear thickening and shear thinning, which is plastic and elastic fluids. For shear thinning, we can say milk or any other thing, and for shear thickening, we can take honey as an example. And this is Bingham plastic. In Bingham plastic and non-Bingham plastic, there are two types. As for Bingham plastic, we can say, for example, as a toothpaste. All the for Newtonian and shear thinning non-Newtonian fluids, everyone starts from the origin and goes as a straight line for Newtonian, and for non-Newtonian it goes as a curved line for shear thinning or pseudoplastic and viscoelastic fluids. For pseudoplastic fluids, which is a shear thickening fluid, it goes from the downward direction of the Newtonian fluid, which is n is less than 1. And as for shear thinning, which is viscoelastic fluids, in this it goes above the Newton law of fluids, which is n is greater than 1. As for Bingham plastic, it goes in a direction on the it starts from any order from y axis and it goes in a straight line. These are the different types of viscosity, as you can see. In this slide, we have discussed about viscosity, what are the types of viscosity, and what is Newtonian fluids, non-Newtonian fluids, and what is the shear rate, stress test, and all the equations related to it. Thank you.